In this quick PowerPoint presentation, I'm going to be talking about variation and some of the different aspects of equations that require variation, and we'll go through a couple of examples. There are 4 types of variation. The first type is called direct variation, and we'll know that we're supposed to use direct variation because our problem will say that y varies directly as x, or y is directly proportional to x. And if we see that, that means we want to use the equation y equals k times x. Now we see the y and the x in the sentence, but we don't see the k in there, and we'll talk about that on the next slide. The next type of variation is inverse variation, and we would see y varies inversely as x, or y is inversely proportional to x. And when we see inverse variation, that means we want to divide. So we would set up the equation y equals k divided by x. The third type of variation is joint variation, and we would see y varies jointly as x and w. And jointly just means we're going to be multiplying by several different variables. So we would use the equation y equals k times x times w. The last variation doesn't really have its own operations that go with it. It's combined variation, and this is just a combination of any of the above 3, direct, inverse, or joint variation, but we only use one k. We're setting up just one equation with potentially multiple types of variation in it, but it's only one k value that we use. For example, we may see y varies directly as w and inversely as the square root of z. And what we want to do is set up one equation that multiplies by w and divides by square root of z, because that's what direct and inverse means, but there would only be one k in the problem. And we're going to go through a couple of examples of each of these and see exactly how to set each one of them up. So we would have y equals k times w divided by square root z. The k that you kept seeing on that last slide is called the constant of variation, and it is unique to each problem. It is a constant, although at the beginning of the problem we don't know what its value is. Once we figure out the value, it will stay that value for the rest of that problem. Anytime we see a problem that says variation, we are expected to understand that that means there is a constant of variation in there. There will be a k in there. They will never tell us to put a k in there. We need to understand that when we see variation, that means there's also going to be a k in there. And usually enough information will be given in our problem so that we'll be able to solve for the value of k. So there are a few steps that we need to follow every time we're solving a problem that involves variation. The very first thing we need to do is always just set up a basic equation that uses the correct variables that we were given in the problem and the types of variation, whether it says direct or inverse or joint or a combination of them. We need to set up that first basic equation to use. Once we have our basic equation, we should be given a set of values that we can plug in to solve for k. Once we know the value of k, we can rewrite our basic equation with the value of k plugged in. And this now is our equation of variation with the k value plugged in. Some problems ask us to go one step further than that, and once we figure out our equation of variation, ask to solve for one of the values, and we'll be given a second set of values to do that. So we'd find our equation of variation through step number 3 and then plug in some more values for our variables to solve for one final value. This step is not always required. Some of the problems just ask you to find the value of the variation constant in the equation of variation, which would just require us to go through step number 3. So for our first example, we want to find the variation constant and an equation of variation for the given situation. Y varies directly as x, and y equals 3 when x equals 12. The first thing we want to do is look at the variables we are given and the type of variation so that we can decide how to set up our basic equation. It says y varies directly as x. That means we want to use y equals k times x. That is our basic equation. The second step is to use the values they gave us to solve for the k. It says y equals 3 when x equals 12. So we can substitute 3 in for the y and 12 for the x to that same equation, and we get 3 equals k times 12. And we can now solve for the k because that's the only unknown value left in that equation, just by dividing the 12 over to the left-hand side of the equation. And we get k equals 1/4 when we simplify. That is the value of our variation constant, which is one of the things we were asked to find. The second thing we were asked to do was find the equation of variation, which means I want to go back to that very first equation I set up, but plug my k value in. So we would say y equals 1/4 times x, and that would be our equation of variation. Another example. Find the variation constant and an equation of variation for the given situation. M varies inversely as the square root of t, and m equals 2 when t equals 5. The very first thing we want to do is look at the variables being used and the type of variation that we are asked to use. M varies inversely as the square root of t. That means our equation is going to involve division. M equals k divided by the square of t, so t squared. Once we have our basic equation, we can plug in the values they gave us. We're told that m equals 2 when t equals 5, so we can go back to our basic equation and replace m with 2 and t with 5. And we'll get 2 equals k divided by 5 squared. Well, 5 squared is 25, so that's equivalent to 2 equals k divided by 25. And since k is the only unknown value left in that equation, we can solve for k by multiplying both sides by 25. And we get that k equals 50. That is one of the values we were asked to find. The original problem said find the variation constant, which is k, and we were able to find that k equals 50. The second part of the problem says find an equation of variation. We found a basic equation, which was m equals k over t squared, but now that we know our value of k, we want to plug that in, and we get m equals 50 over t squared. So our equation of variation is m equals 50 divided by t squared. We're going to do one more example, and in this example, we're going to be asked to perform that final step where we actually go beyond just finding the equation, but finding a specific value. If y varies jointly as x and the square root of w, and y is 12 when x is 3 and w is 64, find y when x is 8 and w is 9. Now that is a lot of information in just one sentence, so the key is to break this up into steps. There are 4 specific steps we need to follow. Look at the first part of that sentence, and it tells us how to set our equation up. Y varies jointly as x and the square root of w, which means y equals, jointly means we're going to multiply several things together, x and the square root of w, and because it's variation, we know we're going to have a k in there, so y equals k times x times the square root of w. That is our basic equation, which we can start with. The second part of that sentence gives us some values we can plug in to solve for the k. It says y equals 12 when x equals 3 and w equals 64. So we're going to go back to that basic equation and plug those values in. We get 12 equals k times 3 times square root 64. Well, the square root of 64 is 8, so we get 12 equals k times 3 times 8. 3 times 8 is 24. So we have 12 equals k times 24, and we can solve this the equation for k if we divide both sides by 24 and simplify. We get k equals 1/2. That is our variation constant. Now I'm not going to circle that. That's not one of the things they asked me to find, but that is the second step we need to do in order to finish this problem. Once we know the value for k, we want to rewrite our basic equation with that value plugged in. K is a constant, so once we know that value, k will stay that value for the rest of the problem. So our equation of variation is y equals 1/2 times x times square root w. Now the last part of this problem tells us that we want to find y when x is 8 and w is 9. So we can use this equation of variation that we just figured out and plug in x equals 8 and w equals 9, and everything on the right-hand side is now plugged in, and we can simplify. So the square root of 9 is 3, and half of 8 is 4, so y is equal to 4 times 3, therefore y is equal to 12. We were asked to find y, and we have found y equals 12. I hope this was helpful. If you need to, go back through it and pause it and try some of the examples on your own, and the most important thing is to remember those 4 steps.